I hope you're doing good today. We're moving on to lesson 6.5, which in circles, there's going to be something called tangent lines, okay? So let's look into this, and it's just going to add to the stuff that you can use whenever you're dealing with circles. Let's jump into it. Okay, so the first thing I want to talk about, and I want you to draw it right here underneath this, is specifically exactly what I mean by a tangent line. So if you have a circle, let me go ahead and get this going. If you have a circle, and then in that circle, a line is going to touch the circle at exactly 1 point. So it's going to be a line that is touching the circle at exactly 1 point. That is going to be known as a tangent line. So actually, if I was to draw the radius going to that 1 point, that would form a 90-degree angle. Okay? So that, ladies and gentlemen, is specifically what a tangent line is. Okay? So let's go and look at some theorems that we're going to use when dealing with tangent lines. So intersecting tangent segments are equal in length from the same point outside the circle. So what that means is that if I have a circle and I have a line that is tangent to the circle going out this way, and I have a line that is tangent to the circle going out this way, if those two segments are tangent to that circle, meaning touching the circle at 1 point, and they're intersecting outside here, that means that those two line segments are going to be congruent to each other. So that means if this is point A, and this is point B, and this is point C, this would mean that AB is going to be equal to CB. So again, tangent lines that intersect outside the circle are going to be congruent to each other. Okay? All right, the next one says the measure of the angle formed by the intersection of two tangents outside the circle is half the distance should be difference of the intersected arcs. And what that means is, if I have a circle down here, and inside the circle I have two tangent lines, meaning touching at exactly 1 point and they're intersecting outside, if I wanted to find this angle right now, and I'm going to call that angle A, I need to take the two arcs, subtract them, and divide by 2. Okay? So let's go ahead and say that this is point B, and this is point C, and then I actually have a point out here. I'm going to call it E. Okay? So right now, if I wanted to find angle A, I have to take 1/2 the measure of the difference of the two intercepted arcs. So that means right now I'm going to take the bigger arc. So I got BEC. So I'm going to take arc BEC, and I'm going to subtract arc BC. So I'm going to take the difference of this arc and this arc and divide it by 2, and that's going to give me angle A. So what we're going to do is we're going to take these theorems, we're going to apply it to our examples, and then hopefully you guys can understand what's going on. Make sure you ask some questions. All right, so first thing, look at example number 1. It wants me to find the value of x. Well, right now, 3x plus 2 is dealing with this line right now, and it looks like it's touching the circle at exactly 1 point tangent line. 5x minus 18 is this line right here, and it's touching exactly 1 point. Again, it's not necessarily a part of the problem, but I just want to let you know the radius that is touching at that point is going to make 90-degree angles, just so y'all know that. Well, I know from my first theorem that if I have two tangent lines that are intersecting outside of the circle, that means this line is going to be equal to this line. So that means 5x minus 18 is going to be equal to 3x plus 2. So I'm going to subtract 3, which will give me 2x. I'm going to add 18, which is going to give me 20. I'm going to divide by 2, which is going to give me 10. So that means x is going to be 10. Okay? So again, two tangent lines meeting outside the circle are congruent. Okay? Let's jump over to example number 2. So on example number 2, it wants me to find the measure angle of EFD. So EFD, it wants me to find this guy right now. So I know if I want to find EFD, I need to take the two intercepted arcs, subtract them, and then divide it by 2. So right now I have 124. I know the whole circle is 360, so I know from E to D this way, I have to do 360 minus 124, which is going to end up giving me 6, 3, 2, so 236. So that means if I wanted to find angle F, I have to take 1/2 the measure of 236 minus 124. Okay? So right now, 236 minus 124 is 112. And then I'm going to take half of 112, which is end up going to give me 56 degrees. All right, so look at example number 3. There's something you need to add in there. Real quick, go ahead and put .s somewhere on the outside of this circle right here. And then I want you to add RSP, arc, is going to equal 211. So right here in this example, it says the measure of angle PQR. So PQR, this angle right now is 31. And then it says, what is the length of arc PR? So I need to find this arc right now. What I do know is to find this angle right now, I have to subtract the bigger arc minus the smaller arc and then take 1/2 of it to give me 31. So let's go and work that out. So with that being said, I'm going to work it out over here on the left side. So 31 is going to be equal to 1/2 the measure of RSP, which is 211. And then I'm going to subtract what PR is, which is going to be X. So right now I'm multiplying by 1/2, which is the same thing as dividing by 2. So I'm going to multiply by 2 on both sides. So that's going to cancel. So I get 211 minus X is going to be equal to 62. Then I'm going to subtract 211 on both sides. So it's going to cancel. So I get negative X. And then 62 minus 211 is going to give me 149 or negative 149. I can't have a negative X, so my answer is going to be 149. So that means PR is going to equal 149 degrees, okay? And then lastly, it wants me to find what QR is. Well, I know these are two tangent lines, so the two tangent lines are going to be equal to each other. So that means this line is equal to that one. So that means 0.5x plus 9 is going to be equal to 4x plus 5. So I'm going to subtract 0.5 on both sides, which will give me 3.5x. I'm going to subtract 5 on both sides, which is 4. I'm going to divide by 3.5. So 4 divided by 3.5 is going to give you, x is going to be 1.14 is going to be your answer. Okay? And that's going to be the value of x. So right now, ladies and gentlemen, take this info, apply it to your skill check, and let me know if you have any questions.